Okay, let's see how it went. So the antiderivative of 1 would have been x plus c. The antiderivative, or the integral of 0, would have just been a constant. If we had 6, it would have been 6x plus c. And then let's try the next row. So the antiderivative, or the integral of 4x. So what we're going to do is we're going to add 1 to the exponent and then divide by that new exponent. So 1 plus 1 is 2. And don't forget your plus c. And then let's tidy that up. 4 divided by 2 is 2. So we have 2x squared plus c. And remember, you could always check your answer. So what is the derivative of 2x squared? The derivative of that is 4x. The derivative of c is 0. So yes, we got the right answer. Okay, so of course we can always go and check new answers on these by taking the derivative, because we're really good at taking derivatives now. Okay, next one. So big F of x would be equal to 3. Just put that out the front, then add 1 to your exponent, divide by that new exponent, add c, and then tidy up. So 3 on 3 divides out nicely, and so we're left with x cubed plus c. All right, now we're changing to a g. So that's easy. Just write a big G. Change the letter up just for fun. So we would add 1 to our exponent, 5 plus 1, divide by that new exponent, add c. So that's equal to 1, 6, x to the 6 plus c for g of x, big G of x. All right, get into some that have some more stuff going on. So these are these ones where we're adding or subtracting functions together. So you just got to do this process with each of them. Okay, so we have big F of x is equal to, so we are going to have 4x cubed plus 1, so 4 over 4, minus 6x, 2 plus 1 is 3 over 3, plus 11x plus c. And then we would tidy that up. So we had x to the 4th minus 2x cubed plus 11x plus c. And then again, you can always check your answer, take the derivative of that and see if you got it right. All right, so let's look at this one. Big H of x is equal to 6x, 3 plus 1 is 4, on 4, minus 3x, 1 plus 1 is 2, on 2, plus 8x. Now we have this radical, so just remember this guy is x to the half, and we're going to have to add 1. So to add 1, make a common denominator. So he becomes 3 halves. Okay, so this is plus x to the 3 halves. And then, yes, we have to divide by that funky fraction and add c. And then we'll tidy this up. So this is equal to 6 on 4 reduces to 3 halves, x to the 4th minus 3 halves, x squared plus 8x. Now, if you divide by 3 halves, you multiply by its reciprocal 2/3. So this is plus 2/3 x to the 3 halves plus c. Sneaks in there just nicely. Okay, and then we have something that's a little more generic. So this would be capital H of x is equal to, a is just some constant, and then this is x to the power of n plus 1 divided by that new exponent n plus 1 plus c. Oh, and now we're going to get into some trig. All right, so let's think of this. This is big G of x is equal to -4. Let's put the constant out there. What would be the antiderivative of cos? That would be sine of its argument, 2x plus 3, divided by the k. Now, the k is the coefficient on x, okay? That's the guy that goes underneath. and then we have our plus c. So this is equal to negative 4 on 2 is negative 2. Sine of the argument, 2x plus 3 plus c. Now, we're just going to pause here for a second because we haven't really seen in our previous antiderivative table a plus 3 added on. So that plus 3 is not going to affect anything. The part that would affect something in our antidifferentiation process is if this guy here had something higher than an exponent of 1. So we had like a 2x squared, a 2x cubed, something to that effect, then we have to use a different process, and that's called the substitution rule that we're going to learn in the next part, okay? So at this point, the plus 3 thing is irrelevant. That doesn't matter, okay? So the only way this rule works in this scenario is if we have a linear x as part of our argument, and then it doesn't matter if you have a constant added on to that argument or not. So it could be 5x, 7x, it could be 10x plus 2, okay? That part doesn't matter, but as soon as we throw in an x squared and an x cubed, now we've got issues and we got to do a different rule. All right, let's do some more. All right, so in this case, I've got g, so g, big G of x is equal to, I'm just going to leave my constant out the front, and then I'm going to think of what is the antiderivative of sine. That is negative cos of my argument divided by my k value, and then I would write that as negative 8/3 cos 3x. Okay, what about L? Well, I might want to write this as 3x to the negative 2. That might be easier before I start my process here. I lost my letter. Okay, so this is big F of x is equal to 3 multiplied by x to the power of negative 2 plus 1, which is negative 1 plus c. I just realized in the previous question I forgot my plus c. So easy to forget. Now I want to go back and check. Okay, I got it on the other one. Okay, guys, so even Malmstrom has problems remembering the plus c. Okay, so here we go. Back to blue. Let's see, what would this tidy up to? We would have negative 3x to the negative 1 plus c. We could write that as negative 3 on x. That might look a little prettier as our answer, but negative 3x to the negative 1 is also acceptable as long as we remember our plus c. Not always easy to remember. Okay, h of x. I'm going to go purple. H of x is equal to, what is the antiderivative of sine? It is negative cos of the argument divided by the coefficient on x, which is 2. That's your k, plus, we have another one of these guys. We might want to write that as x to the negative 2 so that it's easier to add. So we have x to the negative 2 plus 1, all divided by that new exponent, which is negative 1, plus c. And then we will tidy this up. So we have this is equal to negative 1/2 cos of the argument. What is this? Minus, this could just all be 1 on x plus c for h of x. And lastly, we have, maybe I'm going to rewrite this one out first. So let's see, little f of x, because I'm rewriting it, 2x to the negative 2 minus 5x to the negative 1/2 plus x, just so it's easier to do my process. All right, so now big F of x, the antiderivative is 2x to the negative 2 plus 1, which is negative 1. So divide by that, minus 5x. Now we're adding to this negative 1/2, so add 2 on 2, that's adding 1, gives me a positive 1/2. Don't forget to divide by that ugly fraction, plus x, 1 plus 1 is 2, on 2 plus c, and then we tidy up. So this would be equal to negative 2 on x. So if I am going to go 5 divided by half, it's really the same as 5 times 2. So minus 10 root x plus 1/2 x squared plus c. How did that go for you? Hopefully it went fantastically. Okay, let's try example 3. This is telling me I know the second derivative and I need to find little f of x. So I'm going to have to find f prime of x and then go to f of x. So I just have to do the anti-differentiation process twice. Okay, so f prime of x would be 2x 2 plus 1, which is 3, divide by 3, minus x, 1 plus 1, which is 2, divide by 2, plus 7x plus some constant c, which we might want to just quickly tidy up before we move to the next one. So 2/3 x cubed minus 1/2 x squared plus 7x plus c. So that would give me the first derivative. Now I want to find little f of x. And really, if we were thinking about little f of x being the first derivative, then this guy actually would be the third derivative. Doesn't really matter. We just have to understand the notation and how far we have to go. How many times do I have to go backwards? Okay, so I'm going to now go to little f of x. So 2/3 is my constant. X to the power of 3 plus 1 is 4, divided by 4. Maybe put this in brackets to know I'm going to multiply that in a minute. Minus 1/2. X 2 plus 1 is 3 over 3 plus 7x squared over 2. Ooh, now we have to add to a constant. So remember, if it had been 5, we would have 5x. So this is going to be cx, but we have to add in a new constant. So in order to do that, we use a different letter, just so that we can say that we don't really know if those letters are numbers are the same. So we don't want to say plus cx plus c because there's no guarantee that those would actually be the same value. So we would like to use a different letter there to show a different constant. And then we would just tidy this up. So we would end up with 2/3 times 1/4 is 1/6 x to the 4th minus 1/6 x cubed plus 7/2 x squared plus cx plus d. So fun. So hopefully all of those example 2 questions went phenomenally for you, and that maybe you even went ahead and tried 3 before you watched the video, and that you nailed it. Give yourself a pat on the back. And then we're going to look at how do we do ones that are a little more complicated using what's called the substitution rule, and we will do that in the next video. So I'll see you back shortly.